The first question was asking you to solve by elimination. You may recall that on the previous assignment, we solved the same system by substitution. Now, in order to solve by elimination, you have to write both equations in standard form. That means your x and y terms are to be on one side and the constant term, which is just a number, c, on the other. Okay, right here. So once you have it written like that, which is exactly what happened here, you're going to look for opposites in order to drop one of the variables. Now, I have chosen to eliminate y by multiplying the top equation by 2. And that is what made this go away. And then I was left with just x, and then I plug it in and find y. So the same solution, of course, as last time, 6, 7. Now, question number 2, factoring. You want to recall how to factor. Notice that the coefficient of x squared, that is 2. So when you look at ax squared plus bx plus c, what you want to do is you want to multiply a times c. This is what's happening. You get -6. Now you're finding factors, which means two numbers that multiply to give you -6. That would be 2 and -3. Why not the other way around? Because when added, you're supposed to get your b term. Okay, this one. That would be -1 because it says -x. Okay, so that's -1 right here. 2 plus -3, that's -1. That works out. Now, technically, if you didn't have a 2 in front of your x squared, you would just put x plus 2, x minus 3. However, that is not the case because you do have a 2. So you have to divide by 2 right here. Now, that right here becomes a 1, so that's easy. That's fine. Right there. But this cannot be a fraction. So this is where you have to rewrite it in this form. 2x minus 3. Done. Now, at the bottom, it tells you this or that, the commutative property, obviously. FOIL to check, always. Number 3, simplify, square root of 48. You want to know how to prime factor, and this is the factoring tree right here. Now, what's the point? The point is to notice the index. Okay, the invisible index will be 2. That's why we call it the square root of. That's what tells you how many of the same you need in order to simplify. So in other words, if I have 2 squared, I can simplify, the answer is 2. Why? 2 squared is 4, square root of 4 is 2. That's what I'm after, perfect squares. Okay? So then I just rewrote it to notice, oh, all right. 2 squared, square root of 2 squared is 2. So the final answer is 4 square root of 3. Question number 4. You want to evaluate. Please use parentheses. Why? A is to be squared. A is -1. So it has to be in parentheses because -1 squared is +1. Don't have parentheses, you should be getting the wrong answer because then this would stay negative. That would be wrong. Anyway, -40. Cubed obviously means 2 cubed means 2 times 2 times 2. That's 8. And then you multiply that by 4, negative. There you go. Now, with all of these, please understand the importance of finding what they're talking about, 64. Okay, you find it right here, and then you go across and you drop it down. That's how you get 156. Similarly, you're going to apply a similar technique here. You're going to extend the graph, and then you're going to just, they're talking about 40. So 40 would be here, and then you go up to the graph, and then you go to the side. Okay, that's how you get 800. All right, so this one, just like that. Week 5 is the answer. Okay, find 130, go to the graph, best fit, drop it down. All right, question number 8. we're talking about linear functions here, and it's very important for you to notice if x doesn't show an exponent, that means it automatically means a 1. If that's the case, it's a linear function. Okay, now in this case, investigate what m is about. M is a positive number. This one is a rising line. And honestly, only vertical and horizontal lines will be of exception. Other than that, all linear functions will have the same domain and range. Okay? So, and in this case, it's negative infinity into infinity, domain and range. Now, could you write it a little bit differently? Yes. You may have seen that notation where they use parentheses. Negative infinity into infinity, boom. And then you would just indicate if you're talking about the domain or you're talking about the range. In this case, both the same. Now, notice that there is no equal sign. No equal sign with infinity. Okay, so don't write this. When you deal with infinity, no equal sign, no brackets. All right, this one is quite interesting. Okay, this one's quite interesting. And x could be anything. Okay, there, x could be anything, all real numbers. Any x will produce an output. However, here I have something else for you that you could look at. Like in pre-calculus more and later in algebra 2, you would want to possibly show the domain for each piece, for this one and then for the rest of it. Now you notice that, and I marked the 1 for you already. Look at that. Boom. You have an open circle, which means don't count the 1. And then you have a filled circle, which says do count the 1. So considering the piecewise situation here, with that interruption, so to speak, you would say x is less than 1, okay? It's greater than negative infinity, but less than 1. But at the same time, it's also, for the other piece where it takes over, it's greater than or equal to 1 and less than positive infinity. Okay, so that's a union here. The left and the right combined still give you all real numbers. That's that.